So here we go. Just good morning. Happy Monday. Good afternoon, I guess. It's fifth hour now, huh? So apologize I'm not there today. I have an appointment I need to run to. I was here this morning, but I'm not here fifth hour. So ta-da, here I am, but I'm not live. So I'm sorry I'm not available for questions, um, but that's okay. I still like you. Um, Here's what we're doing today. So if you take a look, there's a couple things. If you want to have these out while we're talking through it, that I think would be smart. Um, look at the top. It says your daily targets determine percent composition, empirical and molecular formula of chemical compounds. So we did percent composition last week. You watched an Edpuzzle with it. You did the edu creations with it. And then if you remember on Friday, we reviewed that and went through a couple examples of that. All right, so we've done percent composition. The other thing Friday we talked about was the empirical formula. And then remember there's that four-part rhyme that we learned that goes with that. I'll go review that quickly today. And then today we're going to talk about molecular formula, which I think is the easiest of the three. Okay, so we'll go through that. To do that, you're going to want your periodic table. You want a calculator. You can use your iPad or your cell phone today. That's fine. But then on Schoology, open up those same notes we did on Friday. Remember they're in Unit 6 under the Notes folder. And we'll go through that. My goal is to do this quickly so that you can practice and make sure you understand how to do this. So I'm officially today on the right-hand side over here. You can see there's homework pages 2 and 3 have now been assigned. We assigned page 1 on Friday, so now you have page 2 and page 3, and you should have plenty of time today in class to work on it. Okay, so let's do this. Remember on Friday we talked about empirical formula. We said empirical formula is when you reduce those subscripts, right? It's the smallest whole number ratio of atoms in a compound. So the example we used on Friday was C2H6 can be reduced to C1. There's really a subscript 1 there. C1H3. We can reduce both those just like we would a fraction. We talked about that on Friday. And then remember, we said there's a little ditty, a little rhyme. There's 4 things to remember with the empirical formula. And here they are again. And they're written down in front of you. Percent to gram, gram to mole, divide by the small, and make them all whole or round to the whole. So remember to do that. We want to assume we have a 100-gram sample, and then you can directly just turn the percents into grams. You don't have to do any calculation. If it says 24% carbon, just turn it to 24 grams of carbon. Then you have to do 1 molar step, molar conversion from grams to moles, right? So I multiply by my fraction, 1 mole's on top, and the grams are on bottom. Remember, I look at my periodic table, right? I find the molar mass, and that's the grams on bottom. That'll give me my amount in moles. Then I take my molar conversions, and again, if I had 3 elements, I would have 3 moles. I would look at those 3 or 2 or 4, and I'm going to say which one's my smallest number. Of those elements, I'm going to take the smallest one and divide all of them by that smallest one. Then that'll give me a number there. I'll take those numbers and I need to round them by to the nearest whole. Those final numbers then after step 4, I'm going to take those and plug those back in as subscripts. Okay, that's what we did on Friday. So hopefully you remember that. I'm not going to go over that again. I will post on Schoology. If you're like, I don't get this empirical formula thing, I'll post a video. I think I'll just title it Extra Help Empirical Formula. All right, and you can watch that if you're still struggling, not quite sure. It's pretty clear. I think it's pretty well done. Okay. Today, what I want to do is I want to get to the molecular formula. Molecular formula is almost the reverse of the empirical. If empirical is the reduced formula, the molecular is the true formula. We've been working with molecular formulas all year long, so this is nothing new. All right, it's the actual number. So back to the screen, CH3 is the reduced. The molecular would be, for example, C2H6. That is the actual, the true formula. Okay, now can I reduce that? Yeah, but molecular form is not looking for the ratio, it's looking for the actual number of atoms in a compound. And so that's called the molecular formula. Again, this is nothing new. We've worked through this all year long. Okay? So how do you determine molecular formula? There's 4 steps, and you can write them down. Step 1, find the empirical formula. Step 2, find the empirical formula mass. Step 3, divide the molecular mass by the empirical mass. Step 4, multiply each subscript by the answer from step 3. You can write those down. I think it's helpful to see step by step, but I think those little 2 graphs at the bottom are even more helpful. So look at the little box, that brown box on the left. It says MF mass over EF mass. MF stands for molecular formula mass, the actual true formula. What is the mass of that? I'm going to put that over my empirical formula mass. So I need to find the reduced ratio. Okay, if I go back again, CH3 would be the empirical, C2H6 would be the molecular. So I would find the mass of the bottom one, the C2H6, that would go on the top. The reduced one, CH3, the empirical formula, that would go on the bottom. And then I divide them. Okay, I take the mass of the molecular divided by the mass of the empirical. That'll give me N. Then what I need to do is I take that N and I'm going to bring it back over to the empirical formula and plug it in as a subscript. Okay, so if N is 1, empirical formula doesn't change. If N is 2, I double the whatever the atoms are in there. If it's 3, I triple whatever atoms are in there. All right, let's give you an example. So I know I have the answers up here on the screen. And I wish I didn't, but I do. But look at the question. It says the empirical formula for ethylene is CH2. Now, again, empirical formula. It's the reduced, right? It's the reduced. So CH2, you cannot reduce that anymore. Then it asks, find the molecular formula if the molecular mass is 28.1. So look at the brown boxes again. I just gave you the bottom EF mass. Sorry, excuse me, MF mass on top. Okay, I gave you the molecular mass, 28.1 grams. Again, going back to the box, that's what's on top, the MF mass. So what I got to do is I got to figure out the empirical mass. Well, how would I do that? Well, it starts with finding the empirical formula, which in this case is CH2. Then I find my periodic table. I find carbon, all right, which is 12.011. And I find hydrogen, which is 1.008. I multiply that by 2, right, because I have 2 of those, and I add it to the carbon. That mass of my empirical formula is 14.02 grams. That then goes on the bottom. Why? Go back to the formula, right? Go back to the formula. What's the formula say? Formula says molecular formula mass over empirical formula mass. So again, the molecular formula mass I gave you, that goes on top. The empirical formula you got to calculate by looking at the periodic table. That goes on bottom. And then you just divide them. 28.1 divided by 14.3 is 2. Now, is it exactly 2? No, you're going to round that. But it's pretty darn close. All right? It's 2. That number right here then is N. Now go back one more time. All right? Go back one more time. Look at the N. The N I'm then going to insert back into the empirical formula. So my empirical formula was initially CH2. I'm going to take this as my N, right? That 2 is going to go right here. I'm going to plug that into N, and then I multiply it out. Now I have C2H4. 2 times 2 is 4. This is my molecular formula. It's my actual formula. Now, can that be reduced? Absolutely. But the reduced is the empirical. So doesn't this reduce back up to here? C1H2. Okay, that's the empirical, reduced. This is the molecular, actual or true formula. And that's how you solve for it. Okay, so that's it. That's all I have. What I want you to do then is you have time to work for the rest of the period, time to work on page 2 and page 3, and this is it. You're just going to calculate molecular formula. So what do you need for that? You need the molecular formula. You need the empirical formula. You need to divide them, solve for n, and then plug that n back into the empirical formula as a subscript, and you're done. Okay. Good luck. Give it your best shot. We'll try and help you out tomorrow if you have any questions. But go ahead and get a good start on it. I know in my first hour, I had a number of students that finished page 2 and page 3. They had no homework. So you can too. All right. Ciao.